replacement reactions and solubility rules. So in this lesson, we're going to be determining the states of matter of products in a chemical reaction, specifically a double replacement reaction. We're going to be identifying ionic compounds as either soluble, so L-U-B-L-E, or insoluble, sorry about that. And then we're going to be predicting whether or not a reaction will occur. And we're going to be doing all of these things with a list of rules we call the solubility rules. So I am going to be working out of pages 47 through 53 if you'd like to follow along in your workbook. You're not required to have those for this, but it might help you a little bit if you want to jot down some notes or do some sample questions in there. So let's go ahead and get started. What exactly is happening in a double replacement reaction? Last lesson, you should have done a little bit of practice with predicting the products of a reaction. What we're going to be doing today is determining whether or not the state of matter of your product is aqueous, something that's dissolved in water, or solid. So let's look at an example of this. In this reaction right here, we have sodium iodide in an aqueous solution. So these ions, the sodium and iodide ions, are going to dissolve in water. And then we have lead 2 nitrate, and we have lead 2 ions and nitrate ions dissolving in water. But when we combine these two beakers, these two solutions, we're going to end up with something that looks a little bit different. So instead of us just having all 4 of these ions floating around in solution, we are going to have sodium nitrate that forms an aqueous solution. But then we also end up with lead 2 iodide that forms a solid. And what you would see is, these things forming a solid, maybe floating to the bottom or sinking to the bottom of a beaker. So let's actually look at this demo, a real example of this. I have a bit of a video inception here, a video and a video. So here this teacher has sodium iodide that he's pouring into a beaker. Notice it's clear, it's transparent. And then he is going to take this other solution here. This is the lead 2 nitrate, also clear and transparent. And he's going to pour that into the sodium iodide. So let's take a look and see what happens. So we end up with this yellow, what we call a precipitate, forming in the reaction. So what he's going to do now is hold up a beaker from a previous class where he let it settle, and we had this precipitate that all floated, sank to the bottom of this beaker. Notice that we also have this yellow. We can tell a chemical reaction happened because there's a yellow solid that's formed. There was a color change. So what exactly is going on, and how do we know that that is going to be the lead 2 iodide, which that's what that is. The lead 2 iodide was that yellow stuff that's formed. Now you might have, if you think back to the demo that we did at the beginning of this unit, a month or so ago, we did something very similar and formed that with our demo with potassium iodide rather than sodium iodide. So anyway, let's figure out what exactly is going on and how we can know what the states of these products are. So if you take a look at page 49, and you might also recognize this because it's also on the very last page of your workbook, we have a list of something that we call the solubility rules. So the solubility rules are going to tell us whether an ionic compound is soluble, meaning it's going to dissolve in water and form an aqueous solution, or insoluble, meaning it's going to form a solid. So let's take a look at the solubility rules for these 2 compounds. These were the products of the reaction we just looked at. So we have sodium nitrate, NaNO3. Now notice that when we're looking at our solubility rules, you're always going to kind of start from left to right, and we're always going to be starting by looking at the anion, which is the negative ion in your compound. In this case, we know that sodium is always going to have a charge of +1 when it forms an ion, and nitrate, one of our beloved polyatomic ions, is going to be -1. So if we find nitrate over here, here it is, we start here and then work your way over to the right, it looks like any positive ion, no matter what it is, when it has formed an ionic compound with nitrate, it is going to be soluble, meaning it's going to dissolve in water and it's going to be aqueous. So this is soluble. So now let's take a look at this lead iodide. So lead 2 iodide, we have a +2 ion here with our lead and a -1 ion with our iodide. I'm going to find my anion first, which is the -1, so I'm going to work my way down. Here we go. Iodide. Oh, whoa. You can't even see that now. Let's try that again. Sorry, still getting used to this new way of doing things. So here is my iodide ion. And then we have kind of two situations here that we can see with iodide ions whenever we have this in a compound. So we now need to look at what our cation is. Our cation is lead 2, Pb +2. So lead and iodide, when these two things come together to form a compound, it is going to form an insoluble compound or a solid. So this was that yellow stuff that we saw falling to the bottom of the beaker in that demo. So let's do a little bit of practice with predicting whether or not compounds are going to be soluble or insoluble. We have a list of questions on page 50. We're going to do a few of those, and these are also going to be questions you have to answer in this video. So let's do the first one together. We have BaCl2, or barium chloride. So if we have barium chloride, we need to figure out what our ions are before we can determine whether or not we have a soluble or insoluble compound. So barium is always going to have a charge of +2. Chlorine is always going to be -1. So let's take a look at our solubility rules. So I'm going to start here at the top, look for my anion, which is chloride. If I work my way down, here we go. We've got Cl right here. And then remember, we have two kind of circumstances here with chlorine or chloride. And barium is not listed in this top row, which means that barium is going to fall into this category, being any other positive ion. So then if we look over here, our barium chloride is going to be soluble. Now, one thing that's a little confusing about this is that we have S and I, meaning soluble or insoluble. This does not mean solid, this means soluble. So our barium chloride is going to be soluble. So go ahead and reference your solubility rule table and answer the questions on the video here, and then we'll work our way up through. Okay, so now that you've had a chance to practice identifying whether compounds are soluble or insoluble in water, let's see how that translates into determining whether or not a double replacement reaction is going to occur. So what we're going to do is, first of all, predict our products, which was our topic of the last video. So if that's still something that doesn't make sense, make sure to reference back to that. But we're going to end up with KCl, potassium chloride, and then CaCrO4, or calcium chromate. So now what we need to do is predict whether or not these products are soluble or insoluble in water. So let's reference back to our solubility rules here. Let's look first for KCl. Sorry. All right, so KCl, we find KCl or Cl right here. Potassium, or K, is going to fall into this category of any other positive ion. which means that our KCl is going to be soluble or form an aqueous solution. So go ahead, make a prediction on calcium chromate, on what state of matter we're going to have there. Okay, so as you hopefully determined, calcium chromate is also soluble in water. So when we have calcium chromate and potassium chloride formed in this reaction, we end up with two aqueous solutions. Now, if you think about that first demo, in order for us to know that a reaction occurred, there was that yellow solid that was formed. In this case, we have two aqueous solutions, and so we don't actually see a reaction. We just have a bunch of ions floating around in the water together. So in this case, there is no reaction. So now go ahead and answer, figure out the products and determine the states of matter for number 2. Okay, so the last thing we're going to be doing is looking at a lab that we were hoping, obviously, that we would be doing in person. We're not. That's okay. We can show you the products for this lab. So if you take a look at page 51, and if you don't have your workbook, that's okay. Just take a look at this table. What we were going to be doing was taking 8 different solutions and seeing if there was reactions, if reactions occurred between all of these different compounds. So, for example, one of the wells we're going to look at were potassium iodide and nickel 2 chloride. So, when we react potassium iodide and nickel 2 chloride, you can write this out as a reaction if that's very helpful to you. I'm going to go ahead and just write that we end up with KCl. And then we also end up with NiI2. So now let's take a look at our solubility rules and determine if these two compounds are soluble or insoluble. So KCl, we seem to continue to run into this one. Some of you might have noticed there's also kind of a clause up here. If you ever have any negative ion, any anion with potassium being one of them, or sodium even, it's always going to be soluble. But we can also kind of double check that with KCl when we come down here and see Cl. Potassium is not listed here in this top one, so that's going to be soluble. So that one is going to be aqueous and it's going to be floating around in solution. Now let's look at our other one, NiI2. I'm going to indicate that this is aqueous. So NiI2, let's take a look and see if this reaction occurs. So NiI2, so we have an iodide ion. Yet again, nickel is not listed here, which means that this is also going to be a soluble, a soluble compound. So we're going to form another aqueous solution. So when these two things come together, we end up with 2 aqueous solutions as our products, which means we don't see any solid formed, which means this is no reaction. So go ahead, pause the video, take some time to make your predictions on what's going to happen with the rest of these reactions. And then once you do that, there will be 2 questions on this video to kind of check your answers. So go ahead and check those as well. Okay, so hopefully you were able to check your predictions. Let's see how your predictions match up with the actual lab results. So we have this picture from when we've done this lab in the past, and you might notice that some of these, like this first one that I did with you all, it was a no reaction. We still ended up with just this clear solution. But with some of the other ones, we can see, especially here, this was very similar to the the one that we had at the very beginning of this lesson, we have this yellow solid that's formed. So we can't really see through that. That's why we have these X's on here, so we can determine if it's transparent or not. So check your answers and see how you did with your predictions. And there you have it. Hopefully that helped you determine what solubility rules are all about and how to predict the states of matter of a product with the solubility rules. If you have any questions, make sure to reach out to your teacher. But other than that, thank you for listening, and we'll talk to you guys later.